Now, let's look at another example. This is Amtrak ridership data, but this data is different from the ones that we used previously. Here we have month and the ridership from January 1991 to March 2004. So this is what we call as time series data. So when you have time series data, the plot that is useful to examine is called a time series plot. Something like this, where you have the time on the x-axis and the y value on the y-axis. Here it is the ridership. Then you can see whether there is a pattern, whether there is a overall trend or there is seasonality. And these are very useful to determining what kind of forecasting model we can use to forecast the y value of interest. In this case, it is ridership. So how to predict what the ridership is going to be for the next few seasons, for example. Okay, again, this is monthly data of Amtrak ridership. Again, we will look at how to do this in SAS. SAS also allows you to do matrix plot, so which means you take a bunch of variables and create scatter plot of all the combinations. So we have here, there are 4 different variables. Okay, that's across the diagonal. So off diagonal, you see that each pair, like that one, okay, and that, like here, it'll be between this variable and this variable. That one is a scatter plot of that variable and that variable. And this one is a scatter plot of these two, and so on. So off diagonal, you have each combination of the selected variables plot. So you can look at a bunch of variables all at the same time to see what kind of relationship, one-to-one relationship exists among the among pairs of predictor variables. So here now you look at this one more closely, then you see that most of the variables are clustered around this edge and very few outside of that. So it's kind of hard to really tell whether there is a relationship that exists here. So what we can do is we can change the scale, okay, to a logarithmic scale. So here it is a logarithmic scale, and when you do that to log scale, it uncrowds the data, and then you can see it more clearly what you cannot see all bunched up together here. Now jittering is another technique to understand the whether data is clustered together very densely, and you can uncrowd the data to see where the data density is. So for example, here this is a scatter diagram without jittering, and here without jittering means that a particular point here could very well have several observations. Like that one, maybe there are 10 different observations exactly the same but represented by just one single point. And here again, so there are, it looks like this area is kind of sparse and this area is kind of dense, but it is possible that this is also dense, not as sparse as what we see, because the values, each and every one of these points are probably several observations being plotted with just one point. So what jittering does is that each of the points is slightly, when they are all the same, a random very small amount is added to the x and y values. So there is a little bit of shift in the position, even though they are supposed to be on the same location. So here you see the points are jittered. So you can see the difference. So here and here. So that's called jittering, and SAS doesn't have a feature for jittering, so we have to just understand what it is and not be able to develop one. Then parallel coordinates plot is useful. SAS has this, and here you take all the predictor variables and plot them in separate axes. What you do then is to convert the values into the same scale, 0 to 100%. So each value of these variables will be converted into a percentile. And then you plot, you take an observation and look at which percentile on CRIM the observation falls, which percentile on ZN, which percentile on INDUS. So you connect these through a line. So each line here is an observation. So each and every observation is plotted. In this particular plot, we have separated out CatMed V0 and CatMed V1. So it gives you an idea as to how the values go up and down among the variables.